IB mock test on chapters 5 and 6, problem number 3. Red elk twirling a stone. Constant velocity. And red elk can do that, right? Okay. On a 35 centimeter long string with a period of 0.850 seconds. The key to this thing is to draw a nice circle. That is not a very nice circle. I'm so sorry about that. Right? Okay. I'm sorry. I'm really sorry. Okay. What is the tension of the string at the top and the bottom? So the period is 0.850 seconds. This radius here is 0.35 meters. The mass is 2.1 kilograms. Right? And so for part A, what is the tension of the string at the bottom? Well, what I'm going to do, since I know the time and the radius, I can find the acceleration. So the acceleration is 4 pi squared r over t squared. So 4 times pi, don't forget to square pi, right, times 0.35 divided by 0.85 squared. Is that what it is? Yeah, it is. Right, and this is 19.12 meters per second squared. Right? So this is the case of where it can be a string. It's an acceleration greater than 9.81. And so at the top, we have to actually pull it downward to make it accelerate downward, and at the bottom, of course, upward. And then we set up our F equals ma. When it is at the bottom, gravity is down. So gravity is, I guess we should figure that out, 2.1 times 9.81. That force is, so store that in A. And then 2.1 times 9.81 is 20.601 newtons. So we're going to use those guys, right? At the bottom, 20.601 newtons is acting down. An unknown force is acting up. And we could set that up, right? Force minus 20.601. Those are all the forces, right? That equals 2.1. And then when you're at the bottom, remember that at the bottom, the center is up. And so the acceleration is positive, right? So positive what this is, right? 19.124, like that, right? And we can calculate that. It's very hard to get these caps on here. Okay, so that's going to be this, so 2.1 times my acceleration plus the answer I just got. So that is, this force works out to be 60.762, etc. newtons. I'm not rounding to sig figs, but there it is, right? It's rounded on your sheet, kind of. And then the only difference is at the top, the force of gravity is down, and the unknown force is, well, probably down, right? Okay. And we can set this guy up. We can go force minus 20.601. The difference is that at the top, the center is below you, and so the acceleration at the top is down. It's going to be a negative number, right? So that equals 2.1 times negative 19.124. At the bottom it's positive, at the top it's negative, yeah? Okay. So now we set it up. I go 2.1 times negative my answer, negative the acceleration, right? Plus that guy, so plus 20.601. And I get that the force is 19.56 newtons negative, right? So this is an upward force because it's positive. This one is downward. This one's up. You got to say that. You got to say that on the test. You got to say this one's upward, this one's downward. You can't just give two numbers because maybe at the top it's actually an upward force, right? Remember that if the acceleration is less than 9.81 meters per second squared, you could have to exert an upward force. I can't remember which one's on the test, but that's your that's how you know. You don't need to know that though. If you set up these equations you'll get actually a positive number at the top if that acceleration is less than 9.81. And then it says, what would be the velocity of the stone if there were a tension of 78 newtons at the bottom? Well, let's set that up, right? What would be the velocity, right? So we could set it up at the bottom. We've got force minus 20 point, oh wait, we know the force, right? The force is 78 newtons, right? Okay. Minus, yeah, okay, so this is upward 78 newtons, right? Because at the bottom you are pulling up. At the top you would be pulling down. Okay, so just, be mindful of that, right? But at the bottom, this guy's a positive 1, minus 20.601. Whoops. Brackets do not match. And that's going to be 2.1 times an acceleration. We can now find the acceleration. So 78 minus 20.601 is 57.399. 2.1a. So a is going to be divided by 2.1. Hey, school day's over. There we have it, right? So this is, the acceleration is 27.33 meters per second squared, but we want to know the velocity. So a is b squared over r, right? And so therefore, velocity is the square root of ar. So the velocity is the square root of this guy, 27.33. And then our radius is 0.35, right? So that times 0.35 is raised to the 0.5 power. Velocity is 3.09 meters per second. Is that what we got? Well, that's a good thing, yeah. And then on that page, the C question, and it's a C and D. There are two unrelated questions to the vertical circle, which is a good thing because vertical circles are dodgy things, right? Okay. And I picked the harder one. It's a centrifuge, and it spins with a certain period. A centrifuge is just a device that spins to generate g-force. And what is the centripetal acceleration, and what is the tangential velocity? So centripetal acceleration, since we have radius and period, I'm going to say that a is 4 pi squared r over t squared, so it's 4 times pi squared times 0.23 is the, and don't fall for the centimeter thing there, right? I give you centimeters on the test, right? And then that's divided by 0.015 squared. That's why it's going to be big, because it's a small period, right? 4 times 4 times pi squared times 0.23 divided by 0.015 squared is 40,355.7, and that's a 4. It's trying to turn into a 9. And then I'm going to divide that by 9.81. This is not something you normally do, but the test question asks you to do that, so I'm going to do it here. The A is 4113.7 Gs. That's how many times 9.81 it is, right? And then then it says, what is the tangential velocity at this point? There's two ways to do this. One way is to just take this acceleration, right? V is from this thing, right? A is b squared over r, so v is a square root of ar. That's what I'm going to do. So I'm just going to say that it's 40,355.7 square root of that times 0.23. Wow. Right, so it's taking me a long time to do this. I'm getting that the velocity is 96.3 meters per second. You can also say that velocity is the circumference. It's not in the data packet, but velocity is circumference over period, so 2 pi r over t. R is 0.23, t is 0.015. You could do it that way. It gives you the same thing. All right.